Hello friends, in this video, I will talk about hypothesis testing using R programming. So before going into the testing of any hypothesis, firstly I'll explain here what is hypothesis and what is hypothesis testing. So hypothesis is generally a statement which is a tentative conclusion. So I can say in statistics, hypothesis is an assumption about population parameter, or we can define hypothesis as a formal statement which gives the explanation about relationship between two or more variables of the specified population. We can say it's a claim about a state of nature structured within framework of a statistical model. So that way we can say hypothesis is a tentative conclusion or it's a tentative statement which we are trying to test with the collected data. So now for that we need to adopt a process or method of hypothesis testing. So hypothesis testing is a method of statistical inference used to decide whether the data at hand sufficiently support a particular hypothesis or not. That means here we are going to check whether whatever hypothesis we have formulated, the collected data support that hypothesis or not. Or I can say whether the sample is too representative of the population or not, that we are going to test with the help of the process of hypothesis testing. So now what steps we need to follow in hypothesis testing? The very first one is we need to formulate or state our null hypothesis and alternative hypothesis. Null hypothesis we can represent by H0 or H0, and alternative hypothesis can be represented by HA or H1. Then after that we need to set the level of significance which we can represent by the Greek letter alpha. So level of significance is what? It is a percent which will say that if the null hypothesis is true, so what are the chance of rejecting it? So that is the committing of type 1 error. Then we need to decide upon what is the appropriate statistical test which we can apply to test the formulated hypothesis. So for that, we need to check what are the variables available in the hypothesis and what are the nature of those particular variables in the hypothesis. Also, sometimes we need to consider the sample size. So that way, we will decide that this is the appropriate statistical test we can use to test the hypothesis. After that, we need to decide whether to reject or whether we are failing to reject any null hypothesis. That decision we need to priorly set. So say for example, if we are testing any hypothesis using any software, so on the basis of the obtained p-value, we will do that decision. So if p-value is less than or equal to significance level, that is alpha, so in that case, we can reject the null hypothesis. That way we can conclude that result is statistically significant. Second case is if p-value is greater than the significance level alpha, so that way we will say that we are failing to reject the null hypothesis and we can conclude that result is not statistically significant. So that way we are going to interpret our results. So in this video, I am going to discuss one sample t-test. So say for example, I am interested to check the mean IQ level of the respondents. So in that case, IQ is a variable or it's a continuous scale variable. So say for this particular variable, I have formulated my hypothesis, null hypothesis as there is no significant difference in sample mean IQ and population mean IQ. Or I can say alternatively, there is a significant difference in sample mean IQ and population mean IQ. So friends, here I am interested to check whether the sample mean IQ is same as population mean IQ or whether there is any difference in that mean value. So that means here we have a variable that is IQ which we want to test using this hypothesis. So for that there are certain assumptions firstly which we need to check to test this hypothesis. So for one sample t-test, assumptions are the variable should be measured on continuous scale, then the variable should be normally distributed, and then there should be no outliers in the variable. So these are the three main assumptions which we need to check before proceeding for the hypothesis testing. So the first assumption we can check here with the help of the variable itself. So we have a variable IQ, and IQ is a variable which we can say it is a continuous scale variable. So now first assumption we have checked only at looking at our variable. Now for the remaining two assumptions, we need to move to the R, and then we will see that how we can apply R, that how we can apply one sample t-test using R. So before that, firstly we will move to the R, and then I'll explain you the hypothesis testing for the one sample t-test in R. So friends, here I am with the R Studio. In that, I'll explain you how we can apply one sample t-test. So firstly, I am writing in comment section. I'm using the hash to write the comment that I am going to explain you one sample t-test in R. So here we will talk about, firstly, we should have some variable. So as according to hypothesis, we should need to create one variable here. So using the C function, firstly, I am creating a vector with certain IQ values. So friends, here I have created a vector of IQ using the 10 IQ values of 10 respondents. So I am executing it by pressing this run button, or also you can press Ctrl Enter from your keyboard to execute or to create IQ vector in R. So it is successfully executed. Now firstly, I'll check the summary of my IQ variable using summary function. So here you can see the minimum IQ value is 111. First quartile for this vector is 109.2. Median value for the IQ is 122.5. Mean is 122.2. Third quartile is 126.0, and the maximum value is 132. Apart from that, we can also check descriptive statistics using describe function. So for that, I am using here describe. In that, I am passing the name of my variable, that is IQ. I am pressing Ctrl Enter. So before pressing Ctrl Enter, I need to tell you one thing here, that this describe function is available in psych package. So now I'm pressing Ctrl Enter. So that way you can see we can get the descriptive statistics of my IQ variable. Now, with the help of skewness and kurtosis, we can get an idea whether my variable IQ is normally distributed or not. So, for skewness and kurtosis, there should be certain ranges. Most of the researchers generally follow ±2 for skewness and ±3 for kurtosis. So according to that ±2 range, I can say my skewness value of IQ variable is in between that range, and also the kurtosis value for IQ variable is in the range of ±3. So that way, on the basis of these two values, I can conclude that my IQ variable is normally distributed. Now, apart from that, there are certain other methods available in R. With the help of that, we can check the normality of the variable. So, second assumption we are checking here. I am writing the assumption number 2, that is normality. We are going to check here. So, for normality, there is a test called Shapiro.test. Inside that, we can pass the name of our variable. So say for example, it is IQ. Now I am pressing this run button to see the output. So we can see the output is in the form of W statistic along with the P value. So I think I have already told this thing, that the P value or the thumb rule of the P value. So here we can say, if we are testing the hypothesis of Shapiro-Wilks test at 5% level of significance, so we need to compare this P value from 0.05. So firstly, I'll tell you what is the hypothesis of Sapir-Whorf test. So the null hypothesis for this test is variable is normally distributed, and alternatively, if our data is not supporting the null hypothesis, we can alternatively conclude that variable is not normally distributed. So from the output of Sapir-Whorf.test function, we can see the p-value is 0.9833, which is more than 0.05. So according to thumb rule, we are going to accept the null hypothesis of Sapir-Whorf's test, and we can conclude that variable IQ is normally distributed. So this is the second way of testing the normality of our variable. Third way is we can use graphical method to test the normality of our variable. So here, suppose I am writing QQ norm function, and here I am passing the name of my IQ variable. I am pressing Control Enter. So we can see in the fourth window, in the plot window, we can see this is the QQ or the quantile plot for the IQ variable. So say for example, if I want to fit a trend line on this graph, so I can use QQ line function. I am pressing Control Enter. So that way we can see here most of the values of IQ variable are following the trend line. So that way I can again conclude on the basis of this QQ plot that the variable is normally distributed. Now we will test the third assumption of the one sample t-test, that is we are interested in finding whether there is any outlier in the IQ variable or not. So for that we can simply use box plot function. Inside that I can pass the name of my variable. I can press Control Enter, and in the fourth window of RStudio we can see the box plot. So from the box plot we can see there is no outlier available in my variable or in my data IQ. If there will be any outlier, so we would be able to see some circles beyond these whiskers of box plot. So we are not finding any circle above or below both the whiskers. That way we can conclude that there is no outlier available in the IQ variable. So that way, friends, we have checked all the assumptions of one sample t-test. Now we are all set to apply one sample t-test in R. So firstly, I'll tell you what is the syntax of one sample t-test in R. So the syntax is we need to firstly use t.test function to apply one sample t-test in R. And in this particular function, we need to pass the name of our variable. We need to give the mu value, that is the population mean value. We can also give the alpha value, that is the level of significance value. And we can also communicate to R whether we are interested in testing two-tailed test or one-tailed test. So that way, these are the certain parameters which we need to pass. Among all these parameters, only variable is the compulsory part here. Mu, alpha and alternative parameters are the optional one. If we will not give the population mean value, in that case, R by itself can take mu as 0. So now we are moving towards RStudio to see how we can apply one sample t-test in R. So now we will see how we can apply t-test here in R. So I'm using t.test function here. I'm passing firstly the name of my variable IQ. That is data I'm giving here. Now, suppose I'm giving mu as 100 because the average IQ value is 100, or the population mean IQ I'm giving as 100. Now, suppose alpha, I'm testing this hypothesis at 5% level of significance, and in alternative, I'm writing the two-sided. That means I am interested in the two-tailed test. Now I am pressing this run button to get the output. So we can see output in the console window of RStudio. So here we can see this is the calculated T statistic, that is 11.744. Degree of freedom is 9. P value is 9.25 into 10 to the power minus 7. That means it is very less. So when we are comparing this P value with the level of significance value, So in that case, we can say this thing that p value is less than 0.05. So that way, we are going to reject our null hypothesis, and then we can conclude there is a significant difference in sample mean IQ and population mean IQ. So friends, this way, this is known as the interpretation part of the one sample t-test using R programming. Apart from that, you can also find one more thing, that is the confidence interval value at 95%. It is 117.9238 and 126.4762. So it means if I'll pick the other sample from the same population, so the mean value will fall in between this range. So this is all about the one sample t-test in R. I hope friends you have found this video helpful for you to understand how we can apply one sample t-test in R. Thank you so much for watching this video. Stay connected for more such videos in R. Thank you.